Hi, my name is Jason Tranter and I have the honour of attending this year's LUBMAT 2016 conference, and I'll be delivering 5 presentations. So, just a little bit about me. I'm the founder and managing director of Mobius Institute. We have training centres all over the world, and I've been involved with condition monitoring, vibration analysis and reliability improvement for about 30 years. So as I mentioned, we've got training centres all over the world, primarily in vibration analysis, but we also teach condition monitoring and reliability improvement. Okay, so the first presentation, which is a keynote address, is called Going Beyond Condition Monitoring to Improve Reliability. Now the basic idea is we're going to talk about condition monitoring and all its benefits, but why, in order to truly gain the most benefit from the program, you need to go beyond just monitoring the condition and improve reliability. So, one of the little simulators we'll use in this presentation is just to explain the idea of the PF interval and the idea of how we detect problems and when we should act. So we have a machine that's traveling along okay, there's some sort of defect initiated, but the condition will then degrade. And we wanted to monitor the machine in order to detect that the condition is worsening so that we can do something about it. Now the problem is that a lot of programs only go that far. We need to go much further. So yep, this is all good. We want to detect the fault as early as we can so that we can minimize the risk and plan for the corrective action that may be required. That's all great, but we do need to go further. We need to say, okay, this is important, this is vitally important, but what if we looked earlier in time and said, well, what were all the root causes of the failures that we're detecting? Things like misalignment, unbalance, looseness, resonance, contamination problems, the way we operate the machines and so on. And what if we went back further in time and looked at what happened the last time the equipment failed, and the work we did, the way we installed the bearings and whatever else, and the planning and scheduling that went into that. And what if we went back further in time and said, well, let's look at the way the strategy works. Let's look at the design and procurement process and the way we store the spares on the shelf and so much more. So that is the basic gist of that presentation. The second presentation I'll be delivering is called Establishing the Asset Criticality Ranking and why it's the cornerstone of any reliability improvement program. And I truly believe it. If you can build a good, solid asset criticality ranking, it can help you to make so many decisions. It can help you prioritize work, prioritize where you're going to spend your time and your money, where you're going to perform condition monitoring, how you're going to manage your spares, so much more. And we're going to go through a little tool to help us explain and understand the whole criticality analysis process so that you can go back and actually create your own asset criticality ranking. We'll be looking at different ways we can assess the consequences of failure, whether it's a minor problem or a major problem. So that's looking at the consequence, and then we'll look at the likelihood of failure, whether both because of the reliability or the condition monitoring technologies that you are or are not employing. That's the likelihood of failure and the consequence of failure. So we'll go through that, explain why you need it and how you can develop it. The third presentation will be on eliminating bearing failures and detecting that the bearing failures are occurring in the first place. And the basic gist is that if we have misaligned machines or unbalanced machines that are out of balance, if we don't install the bearings properly, if we have misalignment or cocked bearings, we put the bearings under tremendous stress and all that extra load. Now bearings are designed to cater with a certain amount of stress, but when we increase that, then we can start to cause fractures to develop, sometimes beneath the surface, and they grow to the surface. So this is one reason why bearings fail. There's lots of root causes, but this is one way. It sort of breaks through to the surface, and that's the spalling that you see. That's one reason. There you can see it occurring there. But also we need to look at lubrication. These surfaces are less than a micron apart, and if we don't have enough lubricant or we have contaminated lubricant with tiny particles that get into, get between the gears or between the rolling elements and the raceways, then we damage the bearing or damage the gears. So these are things we need to be aware of. Okay, the fourth presentation I'll be talking about is an animated introduction to vibration analysis. So the idea is, if you want to learn how vibration analysis works, what its benefits are, what the spectra, time waveforms, phase, and these sorts of technologies are all about, well, this will be the place to learn about it. One of the little simulations we use, which I'll just very quickly use, we can look at the vibration from the bearings, vibration from the shaft and any unbalance that might occur there, vibration from a fan, and I've color-coded this vibration from green from the shaft, green from the bearing, grey from the shaft, orange from the fan. But what happens is we want to be able to split those sources of vibration up so that we end up with a spectrum, and that's where the spectrum comes from, and we can therefore relate any vibration, for example, from the shaft to a peak in the spectrum, from the bearing to a peak, and from the fan to a peak. So obviously we'll be going through all this sort of stuff in more detail. We'll be looking at different kinds of fault conditions and how they make the vibration change, and therefore how the vibration analysts detect these sorts of faults, and lots more. We'll talk about how you detect bearing faults as well, using some of the special techniques designed to do that. Whether it's a fault on the inner race or the outer race or the rolling elements themselves or the cage, we can detect these faults quite easily. Well, quite easily. We can use time waveform analysis to learn all kinds of things that we don't learn in the spectrum. We'll also learn about phase. So, if I've got some sort of vibration that's causing a motion, like unbalance or misalignment that we saw earlier, you can see the two sides moving up and down out of phase. We see a bent shaft again, cocked bearing. All of these fault conditions that you may detect with spectrum analysis. The trouble is it's sometimes difficult to separate which fault it is. Phase analysis helps us do that. So we can either use single channel measurements to get phase or two channels. So we'll just, as part of this presentation, we'll explain time waveforms, phase, spectrum analysis, and some other technologies as well. And last, but certainly not least, we'll talk about the roadmap to reliability. Now, what we've done as part of our training and so on is we've laid out a strategy for how you can improve reliability in your plant. And look, there's a lot to this. Obviously, in these couple of seconds, we can't really go into it in any detail. But as an observation, a lot of companies start with some sort of condition monitoring and maybe some time-based maintenance. You might call it preventive maintenance. And that's great. It needs to be done. But how do you make those decisions? Well, you should be looking at the criticality ranking that there'll be a separate presentation on, and some idea of the failure modes. So that's all good. That ensures that we have a maintenance strategy, which might include some run to failure maintenance as well. So that's all good, but we need to be proactive, get into defect elimination. So that's where we look at the design and procurement process, how we manage the spares, the planning and scheduling, precision skills, precision operation, and then finally the maintain function. Now that's all good, that's all great, but you'll never do this successfully unless you take care of these issues as well. Leadership, culture change, building the reliability culture, understanding people and how they work in a scheme like this, how we can avoid human error or minimize the likelihood, and as part of this training. And last but not least, we look at the continuous improvement, root cause, failure analysis, KPIs and benchmarking and so on. So that's a quick run through what we'll be talking about in that presentation. And they are the 5 presentations that I'll be delivering. So I really hope to see you there at one of these presentations from June 7th to 8th at LUBMAT 2016. See you there.